In this video, we'll break down one of the most important ideas behind decision trees, entropy and information gain, using a clear, step-by-step example. Let's look at a simple but powerful example. We want to predict whether a student will pass an exam, yes or no, based on two features: how much they study and how well they sleep. In this dataset, we have 6 students, 4 passed and 2 failed. So the data is somewhat mixed, not completely clear yet. Now we introduce a key concept, entropy. Entropy measures how messy or uncertain the data is. If everything is the same, all yes or all no, entropy is 0. But here, we have a mix of yes and no, so entropy is relatively high. This tells us we still need to ask good questions to reduce uncertainty. Let's try our first feature, study. If we split the data, high study, all yes, perfectly clean. Low study, mixed, still messy. So after the split, the data becomes partially cleaner. We calculate the weighted entropy and get an information gain value. This tells us how much the split helps. Now, let's try another feature, sleep. Good sleep, all yes, clean. Poor sleep, mixed, still messy. Interestingly, this split gives us the same improvement as study. So both features are equally good at this step. Since both features give the same information gain, we can choose either one. Let's pick study as our first question. Now, we build the decision tree. If study equals high, always yes, we stop. If study equals low, still mixed, we continue. The tree grows only where uncertainty remains. Now focus on the remaining messy group, low study. We try splitting again, using sleep. Good sleep, yes.
Poor sleep, no.
Now everything becomes perfectly clean. Entropy becomes 0. Perfect separation. So now we have our final decision tree. Study first, then sleep if needed. The model has turned messy data into clear rules. Let's test it with a new student.
Study equals low.
Sleep equals good. Follow the tree. Low, check sleep, good, yes. Prediction, pass. Let's summarize the key idea. Entropy equals how messy your data is. Information gain equals how much cleaner a split makes it. And the goal of a decision tree is simple. Always pick the question that reduces uncertainty the most. That's how decision trees turn data into decisions. One smart question at a time. Let's walk through this code step by step to understand how decision trees work in practice. First, we import the necessary libraries. We use pandas to handle data, math for calculations, and scikit-learn to build the decision tree model. Next, we create a simple dataset. Each row represents a student, with 2 features, study and sleep, and the outcome, which is whether they pass the exam or not. Now comes the key idea, entropy. We define a function that calculates entropy, which measures how messy or uncertain the data is. If all values are the same, entropy is 0. If the data is mixed, entropy increases. After that, we define another function to compute information gain. This function tells us how good a feature is for splitting the data. It calculates the entropy before the split, then the weighted entropy after the split, and finally measures how much uncertainty is reduced. We then compute the entropy of the target variable and calculate the information gain for each feature, study and sleep. This helps us understand which feature is better for making the first decision. Next, we convert the categorical data into numbers because machine learning models require numerical input. For example, high becomes 1 and low becomes 0. Then we train a decision tree classifier using scikit-learn. We specify that the model should use entropy as the splitting criterion and limit the depth of the tree to keep it simple. Finally, we test the model with a new example. We input a student with low study time but good sleep, and the model predicts whether the student will pass or not. So overall, this code shows both the theory and practice. First, how entropy and information gain work, and then how a decision tree uses them to make predictions. After I click Run, the result comes out.